Alright, so though this problem looks a little complicated, it's actually pretty straightforward. So let's start writing down the values that were first given. A light triangular plate, OAB, is in a horizontal plane. Three forces, F1 equaling 6 newtons, F2 equaling 9 newtons, and F3 equaling 3 newtons act on the plane. 7 newtons acts on the plane, which is pivoted about a vertical axis through point O. In the figure, F2 is perpendicular to OB. Consider the counterclockwise sense as positive. The sum of the torques about the vertical axis through point O acting on the plate due to forces F1, F2, and F3 is closest to these. So we're actually trying to find the sum of torques. So we can just go and do the torques for each of these values. So the torque of 1 could be, we already know that this one, since they said the counterclockwise sense is positive, this one would actually be negative. So we would do negative times the 0.6 meters that it's going against. And then we would multiply this by 6, the force, cosine of 30. Because in this case, we're trying to find this value. And then that would give us a negative 3.12. And now let's do the torque for the second value. This one is also pretty straightforward. We would just get this number over here, which is the one associated with F2, the length. So it's going to be 0.8 meters. And it's going to be times the force. This one's more straightforward. We don't have to use a cosine or sine since it's only going in the upwards direction. And that would give us 7.2. And now the torque for 3 is just going to be 0 in this case, because it is going in the negative direction down here, and its torque is 0 because of the angle that it's actually placed at. So now we're simply just going to add up all these values, and that's going to give us the sum of torques. So we know that T3 is 0, we know that T2 is 7.2, and we know that T1 is 3.12. And now when we add all of these up, we're left with 4.08 newtons times meter. And that's closest to our option B, 4.1 newtons per meter.